Alright, hi guys, this is part 3. We are going to go over chapter 13.3, which is about energy. I would like to remind you that energy is measured in joules, which is a capital J. So here is our definition of energy, is whenever work is done, energy is transformed or transferred from one system to another. So it could change type, different things like that. So we are going to write these in our Jones notes. But energy is the ability to do work. And I know you guys knew this definition from before, but I'm going to underline that. That's a huge vocab word. So we measure it in joules, which is a capital J. Okay, so measured in joules. Now you guys know that there are lots of types of energy. We've got kinetic energy, we've got thermal energy, potential energy, but we're going to talk about some more specific ones here, being potential, kinetic, and mechanical, and how they kind of work together. So we're going to go through these now. So number 2 is going to be potential energy. Now, I know you guys have learned most of this before, so I'm going to go over it kind of broadly, but I would like you to make sure you guys write all of this down. So potential energy, I'm going to underline, this is a main vocab word, is the energy of position. Okay, energy of position, because it results from the relative position of an object in a system. So I'm going to go ahead and write that. So energy of a position because it results from the relative position of an object in a system. Okay. So potential energy we also kind of think of as stored energy. Okay, you have the potential to do something. So I'm going to move this up a tad. So we in science typically remember the 4 types of potential. So the first one that we always talk about is elastic potential energy. So that's when something is stretched or compressed. Okay, so stretched or compressed. What I mean by that, and I'm actually going to underline these, since these are just types, I'm going to underline these in pink so it still stands out. So what I mean by that would be, so some examples would be a rubber band that is stretched, a spring, a trampoline. So anything that is able to be stretched or compressed has elastic potential energy. If you were going to use a bow and arrow, if you stretch back the bow, you're going to increase the elastic potential energy, whereas when it's completely still and not stretched out, it doesn't have elastic potential energy. The second one that we talk about is gravitational. There's no order for these. I'm just going to talk about each of them, so don't think elastic is like the number one. I would say gravitational is probably the one we talk about the most. But gravitational is anything that is held above the ground. Which makes sense because gravity is going to pull on anything that is above the ground. So anything that is falling is thought of to have gravitational potential energy. So some examples would be if you want to go skydiving, if you want to go cliff diving. Let's say you're on a roller coaster. I believe you guys are familiar with drop zone. When you sit at the top before it drops you, you have a lot of gravitational potential energy. The third one we're going to talk about is mechanical potential energy. Okay, mechanical potential energy is based on the object's position. So this is kind of confusing. So object's position, meaning that it usually has the potential to move. Okay, so we typically, I'm going to explain this, these two are kind of similar. But like, let's say, I give the example, like, let's say your pen is on the edge of your desk. Not moving, just sitting there. If it has the position to fall, like it has the potential to fall to the ground, it's mechanical when it's sitting on the ledge of your desk. So let's say this is the ledge of your desk. It's going to have the potential. So when it's sitting here on the edge, sorry, I'm trying to show you guys. If it's sitting on the edge like that, it's technically mechanical potential because it's not moving yet, but it has the potential to fall. The moment that this pen starts to fall down, that's when it changes to gravitational because now gravity's taking over and taking the pen down. So that's kind of the difference. So the edge of a desk. If you're sitting in a tree, okay, if you have something on the shelf that's like on the edge and it could fall, it has mechanical potential energy. It has that potential, okay, to fall to the ground or to move or roll or anything like that. So I'm hoping that makes sense. The last one is chemical potential. Now this one I think is one of the more obvious of them, but this is any time that it has chemical bonds that will then be releasing energy. So this one has quite a few good examples. So photosynthesis, for my bio fans, photosynthesis is a chemical bond in food. So let's say you eat a banana. It has a chemical bond in it, so it's going to give you chemical potential energy, which then will turn into energy for you and for your body. You digesting is your body transforming that into chemical potential energy. So any type of food. And then another one would be like a battery. A battery stores chemical potential energy in it. And then also things like a match. That's a chemical bond that has the potential to create fire. Again, I know you guys went over this with a review for the 8th grade state test, but I do want you guys to write this down. We have another magical formula. Okay, so potential energy's formula is the mass of an object times the height. Now, we don't use that as much as we actually calculate GPE in particular. So GPE equals the mass times the gravity times the height at which it falls. Okay, so M times G times H. So GPE equals M times G times H. Okay, so what I mean by that is obviously the higher the height or the higher, so the higher off the ground it is or the heavier the mass is, it's going to make that GPE greater, which makes sense, right? If you have a light object that's really close to the ground versus a very heavy object very high off the ground, the GPE is very different. I do want to make note, since I have room over here, G is the gravity, and on Earth it's 9.8 meters per second squared. So I'm actually going to put a little box around that because that's important, and our formula because that's important. So what this is every second, okay, the speed of an object will increase by 9.8 meters per second every single second. So we'll give an example here. So I'm going to flip over the page. Okay, and again, if you guys, I know I'm going kind of fast. If you need to pause it, go ahead and pause it, and then keep writing stuff down. But here's an example of that. So I'm just going to give a real quick. So here's a cliff with my water underneath. So if I have an object here, okay, and this is just showing the acceleration due to gravity on Earth, which equals 9.8 meters per second squared. Okay, so if this person jumps off the cliff and its speed, okay, its speed starts at 0 meters per second. Okay, after, oh, I'm sorry. Okay, if I have, at 0 seconds, it's 0 meters per second. Okay, after 1 second, it's going to increase by that 9.8. So it's going to have a speed of 9.8 meters per second squared. Okay, so it's going to increase by 9.8 every single second. Okay, so 9.8. Then we're going to go ahead and add that again. So now the person, let's say, is at 2 seconds. We're going to add another 9.8, which is that 19.6 meters per second. Then at 3 seconds, it's going to be at 29.4 meters per second. And I'm not drawing this to scale. I'm trying to keep it so it's not taking up too much of my paper. But at 4 seconds, it would be that 39.2 meters per second. And then at 5 seconds, we would be at 49 meters per second. And each of these times, we're just adding 9.8 each time. So 9.8 meters per second every second. So that's what I mean by acceleration due to gravity. Okay, due to gravity. All right, part 3, we're going to move on to kinetic. Okay, kinetic energy is the energy of motion. Okay, anything that is moving, your pen, your brain cells, your lungs, anything that's moving has kinetic energy. Now, it does depend on 2 things. Okay, the 2 things it depends on is the speed. Okay, so what that means is if something is going faster, it has more kinetic energy versus when it's going slower, it has less kinetic energy. Okay. The second thing it depends on is the mass of the object. So if the moving object is heavier, I cannot speak and talk, or speak and think at the same time. If I have something that has, more mass, okay, it's going to have more kinetic energy versus when it has less of a mass, meaning it's lighter, it's going to have less kinetic energy. So if it's heavier and moving faster, it has the most kinetic energy. Okay? Now this one has a formula also. So formula for kinetic energy. So kinetic energy equals 1/2 times the mass times the velocity squared. Now note that you are only squaring the velocity, which is the speed, okay? So let's make sure we, keep that in mind. Okay, so kinetic energy would be 1/2 or 0.5 times the mass times the velocity squared. Okay, so I'm going to give you an example of how to calculate this. So if I have an object that has the mass of 10 kilograms and it's moving at a velocity of 50 meters per second, we would get our formula as looking like this. So we would write kinetic energy equals that 0.5, or that half, times our mass, which is 10, times our velocity, which is 50. But we would square the 50. Okay, so 50 squared is my first step. So I know that's 2,500. Okay, so I would do the 2,500 times 10 times the 0.5. So my kinetic energy equals 12,500 And then the unit that we use is the unit for just energy in general, which would be joules.